going to give you some pointers in how to use this circuit simulation. So when you go to the website where the computer simulation is, it really doesn't matter which one of these you use, intro or lab. I'll click on lab and select it. You can see the field that comes up with wire, battery, light bulb, resistor, switches, wire, fuse, battery, light bulb. It gives you a lot of different items here that you can use in the simulation. Over on the right side, we've got voltmeter, a couple of different ammeters. On wire resistivity, put it on tiny. And then on battery resistance, we want it on 0. So we start out by moving a battery in, and we're going to build a circuit. I'm going to have a battery connected to a wire. Now these wires stretch, but they don't curve. So you can click on the end of a wire and make it be as long as you want it to be, but it's not going to curve. If I put a switch in, I can go there. Then I will put another wire, and I'm going to throw in a resistor, and we're going to go all the way back around till we make one complete circuit. Now, when we build the circuit, nothing's happening right now because the circuit is open. We have to close the switch in order to get electricity to flow. And so you click on the switch to open it, click on it to close it. The battery and the resistor, they have adjustable values. We can click over here where it says values, and it'll show I've got a 9-volt battery, a 10-ohm resistor. If I want to change the battery's voltage or the resistor's resistance, I can click on the battery and see at the bottom it gives me a slider where I can make the voltage go up or down, or you can also go up by 0.5 at a time by clicking on the triangle arrows. If you want to eliminate the battery, you can click on it and then hit the trash can. So now we don't have a battery, I better put another one back in. And if you ever want to disconnect, the way you do that is you click on the connection and then click on the scissors and it disconnects. Disconnect this one. One thing you'll notice, if I don't let go of my mouse, I can pull it off whenever I want to, but if I let go of my mouse, it's now connected. I'm just going to straighten these up a little bit. Okay, so our voltmeter, we click and drag it over to the field, and just like we did with the actual voltmeters, you put one probe on one side of the battery, put the other probe on the other side, and it tells me it's 9 volts. If I switch these, it gives me negative 9 volts. So it's very realistic. If we want to know the voltage of our resistor, I put the probes on each end of the resistor. It tells me the resistor is 9 volts in at this circuit. I can change my value of resistance by clicking on the resistor and using the slider to go up or down. And I can also delete it by hitting the trash can, or if you, maybe this version doesn't do it, but I used to could right click and delete. But it will also allow us to use a non-contact ammeter. If I put this ammeter anywhere on a wire, battery, or a resistor, it will tell me the current in that spot in the circuit. So if you look at your instructions, there's a section that says the following suggestions will help you immensely in building your circuits, determining potential difference in current, and responding to the lab questions. First bullet, to determine the total current in the circuit, place an inline ammeter into the circuit immediately after the power supply. Here is the inline ammeter. So if I take this and put it immediately after my battery, then that will always give me the total current in the circuit. So if I change my battery value, notice it's changing the current. If I change my resistor value, that also affects the current. So one of the questions you're going to be looking at is what happens to the total current in the circuit when you do different things to the resistance, to the battery voltage, or you add additional resistors. The second bullet, to determine the current entering a resistor, place the non-contact ammeter over the wire immediately before the resistor. So there's the current entering the resistor. And then the next bullet, to determine the current leaving a resistor, place the contact ammeter over the wire immediately after the resistor. So you can get the current immediately before and immediately after any circuit element. The fourth bullet, to determine the total potential difference or voltage in a circuit, place the voltmeter in parallel across the power supply. So your total voltage will always be the battery voltage. So if I make the battery voltage go up, notice my total voltage is going up. So that's how you get your total voltage. The total resistance of a circuit, the total resistance of a circuit will be the circuit's total voltage, in this case it would be 59 volts, divided by its total current, 2.68 amps in this case. So to get total resistance, you have to use a calculator and divide this total voltage by this total current. Next bullet, to determine the potential difference across any particular resistor, place the voltmeter in parallel, which means on the positive and on the negative, and that'll give you the voltage of any particular resistor. Next to the last bullet, clicking on the circuit element gives you options for changing the values or deleting. So all you have to do is click on things to get to be able to make changes. And then the last bullet, using this non-contact ammeter will save you a lot of time, because you don't have to put these ammeters in the circuit. You can use the non-contact ammeter and it will give you the current at any given place. Now, you're also going to be adding resistors in series. And the way that you do that is you can just bring another resistor in, get it connected to the circuit. So now I have two resistors in series. To get the voltage across any one resistor, I take the voltmeter and put it on that resistor. So right now the voltage on this one is 18.44. The voltage on the other one is 40.56. And the voltage on the two put together is 59. So you go all the way across. To put resistors in parallel, you will drag resistors up and make them connect to a place, what we call a junction, where the current splits. Here are three resistors in parallel. They have different values of resistance. So if I want them to all have the same value, I can click on the one and move it back down to 10. Now they're all 10 ohms. If I want to know my total resistance when a 10, a 10, and a 10 ohm are put in parallel, I take my total voltage divided by my total current. If I want to know the current through any one of the resistors, I put the non-contact ammeter before or after that resistor. If I want to know the voltage of any particular resistor, I put the voltmeter on that resistor. So you're going to be examining a single resistor. You're going to examine multiple resistors in series, where you put 2, 3, or 4 resistors in series. Then you're going to do equal resistors in parallel, which would be like this one, and then unequal resistors in parallel. So as you work through the activity, you will put your answers in the Canvas quiz associated with this resistance and resistor circuits document.